In this video, I want to talk to you about sampling in ACL. Right, there are three kinds of sampling in ACL. There is record sampling, then we have monetary unit sampling, and finally, we have classical variable sampling. Now, owing to time constraints, we will only look at the first two in this video, record sampling and monetary unit sampling. Now, in addition to choosing the type of sampling we want, that is record sampling or monetary unit sampling, we need to choose which method we are going to use for taking a sample. So let's suppose that I decide to use the sampling type called record sampling. I still need to figure out, should I choose record number 2 to go into my sample, or should I choose record 30 or record 85? How do I know which record to pick for my sample? And that's where the method comes in. There are three methods that we use to choose a sample when we have monetary unit sampling or record sampling. The random method, we have the fixed interval method, we have the cell sampling method, and importantly, please note these three methods apply only to record sampling and monetary unit sampling. Classical variable sampling is a completely separate thing. All right, so we're going to focus on two types of sampling, monetary unit sampling and record sampling, and then we're going to look at the three different ways in which we can choose our monetary unit sample or we can choose our record sample. Right, let us go straight into Excel. Right, in Excel, I have some data, very limited data. You can see this first column here is called record. So I have records 1 up to 6. If I look at a table in ACL, those record numbers I have in that first column A in Excel is this here. Record 1, 2, 3, 4, 5, 6. I've got up to record 6. This column here is the transaction value. Now, these amounts are very small. $2 or £2 or 2 shillings, whatever the currency is, 3 shillings, $3, £3, whatever the currency is, right? It doesn't matter. Now, in practice, those amounts won't be that small. They'll be 2,000 or 2 million and so forth. But for the purposes of this video, I'm keeping these amounts deliberately small. And you'll understand why later I've decided to keep them small. Now, obviously, a table in ACL doesn't have just one column, just the amount column. You would have things like invoice date and customer number as well. But for the purposes of this video, I don't need all those columns in my Excel sheet. I need only these two columns to explain to you how these different types of sampling and these different methods work. Right, so let's suppose I decide to do record sampling. That means I want to pick record numbers. Now, before I can pick a record number, I need to decide which method I'm going to use. Now, remember, there was the random method. I can select my record numbers randomly. There was the fixed interval method, and there was also the method called cell sampling. So let's start off with this. I decide I'm going to take a record sample, and I'm going to use random sampling. So I'm going to look at this column. Because I want to do record sampling, I need to pick record numbers. And because it's random, I'm going to close my eyes, and wherever my mouse pointer lands, I'm going to take that record. So I close my eyes and my mouse pointer lands there, and I close my eyes again and my mouse pointer lands there, let's say, right? So I've picked records 2 and 5 randomly. If I did this again and close my eyes, I'd probably land on some other record numbers. So that's all it is. Now let me do this in ACL. Here is my AR table. I want to take a random sample from here. I want to use the record sampling type, and I want to randomly select my record numbers. Now, it's very important that ACL knows how many records there are in this table. In other words, that it knows the population size, or not necessarily the records in the table, but the number of records you want to give it to use as the basis for your sample. Right now, ACL can already see, in this case, my population size. There are 772 transactions, 772 records in this table. And it is important that ACL knows how many records there are. Because imagine that we told ACL some nonsense. Imagine we said to ACL, in this AR table, there are 800 records. When it then goes to randomly pick record numbers, it might pick record number 790. Because we told it can pick anywhere from record 1 up to 800. And record 790 doesn't exist. So obviously, it can't put that record into our table, into our sample table. So we must make sure we tell ACL the correct population size. All right, now that we've made sure, or that we know at least that this is 772, let's take our sample. We're going to click on sampling. Then we're going to go to the first option, record or monetary unit sampling. And we'll go to the right and we are going to click on sample. So now I see at the top my two sampling types, monetary unit sampling and record sampling. I want to choose record numbers. I want to do record sampling, so I will choose that. The next thing is to come to the left-hand side, to the middle, and to decide my sample parameter. In other words, the method I'm going to use. I want to randomly select record numbers, so let me choose random. Now, I see the population has been filled in, 772. Okay, so there's 772 records that ACL can pick from. I must make sure that population has been filled in and it has been filled in correctly. The size of my sample is how many records I would like to pick from this AR table. So I decide I want to choose 30, so I'm going to type 30. Now the sample command always creates a brand new table in ACL. So I'm going to go next to this word to, I'm going to type the name of my new table. I'll call it sample. I'll write the word record, so we know we're doing record sampling, and I'll put random, so we know we randomly picked records. And I'll click OK. And there you'll see I get a new table with exactly 30 records. Now, if I did this same exercise again, I went back to AR, did the same thing, my new sample table would look different from this one probably, because it's random. It's going to select slightly different ones. Now, the thing is, when you take a sample randomly, when you are working with record sampling, you don't care. In fact, with record sampling, you don't care at all, no matter which method you use. If you picked only big amounts, only small amounts, if you picked some big, some small, you don't care about the amounts. You just pick record numbers. So whether or not the sampling method is good or bad, you can obviously have a debate with someone about it. It's not a simple case of, well, it is always bad to do record sampling because you don't know if you're going to get a nice distribution of amounts, or simply a case of, well, amounts don't matter under circumstances X, Y, and Z. It really depends on what you're looking at. I'm not going to get into all the discussions and arguments about whether to use record sampling, whether to use monetary unit sampling. They each have their advantages and their disadvantages. Most people in the audit environment use only record sampling with the random method. So this is the one I normally teach in training. I don't generally teach the others because, number one, almost no one uses the other options, the other methods and the other types. And when I explain some of those, if people do request them to be explained, I tend to get a lot of blank stares and people phoning doctors for medicine and so forth to help them cope. Right, but most clients do record sampling with the random option. Now I'm going to do another example with record sampling with the random option. I'm going to go back to my AR table. And I decide I want to randomly select 20 invoices. So the first thing I need to do is filter for the invoices. Otherwise, I'm going to include in my sample some credit notes, some payments, things I don't want. So I'll do a quick filter here just to see the credit notes, sorry, the invoices. Now, there is a very fundamental error, a basic mistake a lot of people make in this kind of exercise. They think they can go straight to do sampling. And I'm going to make that same mistake. I'm going to go straight to sampling, and I'm going to go to the first option. I'm going to say, I want to take a sample. I want to pick record numbers, and I want to select them randomly. I want to have a population size of 20. Now notice my population is blank. At this stage, I should say to myself, wait, something is wrong. ACL doesn't know how many records there are. But I'm going to make a mistake the way a lot of people do. And I'm going to go ahead and I'm just going to give the new table a name. And I'm going to call it invoices sample. And I'm expecting to see 20 invoices. I click OK. And what I get is 16 invoices. The reason is this. When I did that filter, ACL did not know. It did not know how many invoices there were. Remember, after you do a filter, ACL has that question mark there. How many of these records are invoices? It does not know the population size. The population size for this exercise is not 772. So because ACL doesn't know the population size, it wildly guesses which record numbers I can pick. It says, well, I don't know, I will pick the invoice, and I'll pick the 7,000th invoice. Now the 7,000th invoice doesn't exist. So ACL can't put the 7,000th invoice in my sample table. That's why I have only 16 records. Sometimes I'll have 16, sometimes I'll have 14 records, sometimes I'll have 18. If I'm extremely lucky, I'll get 20 records. But ACL is going to pick a lot of record numbers that don't physically exist because I forgot to tell it the population size. So what I should do is, after my filter, is very importantly, I need to count, right? What I should do is I need to count quickly so that ACL knows how many records there are. So if I count there, ACL now knows I can pick from invoice 1 up to invoice 588. And I will try this again. I will go to sampling, the first option, and I will choose sample. I want to choose records. I want to choose them randomly. And notice the population has been filled in because I counted. I want to randomly select 20 invoices. And I'll give this new table a slightly different name, invoices sample 1. This is my second attempt at getting an invoices sample. Click OK. And I have exactly 20 invoices. So remember to count. Another common mistake people make is they say, okay, all I need to do is, I don't need to do a filter here in my view. I don't need to do a global filter. I can go straight to sampling and I can go choose my sample command and choose record and random. And then what I'll do is I will use this if button because that is a filter. That's a command filter. And I'll say type equals IN. Now that filter is perfectly correct, but there's a problem. The population size is wrong because it's either going to be the number of records in the table or it's going to be a blank space. In either case, it's wrong. That should say 588 because that's how many invoices we have in this table. So ACL might pick invoice 600, which doesn't exist. So let me give it a try. This I'll call invoices sample 2. I'm hoping to get a size of 20, right? I want 20 records. Let's see what happens. And they only got 14 because ACL's picking non-existent invoices. It's picking invoice number 600, which doesn't exist. And people sometimes think, but why did this happen? You know, I did the filter. Yes, they did the filter, but there's no count command built into the sample command. So I wouldn't bother to use the command filter or the sample command unless I already know the count of the number of invoices. Then I can do that, but I must type in 588 in the population box. Right, so just be aware of counting the number of records you have after a filter always before going to sampling if you're going to do record sampling. Okay, so this is record sampling we did using the random method. Now, I have decided I still want to stay with record sampling, but I would prefer, let's say, to take a random, to use the method called fixed interval. So with fixed interval, you first need to create intervals of the same fixed size. So I decide for argument's sake that I want to have 2 records per interval. So I'm going to go into Excel and I'm going to draw a line after 2 records. There's the first record, second record, right? 1 record, 2 records. All right, let me draw a line there after 2 records. Now I need to start counting again. 1 record, 2 records. Right, draw a line. 1 record, 2 records. Draw a line. So now I have my 3 intervals. It turns out it creates 3 intervals based on the size of the interval I chose and the number of records. I have 6 records. I wanted intervals of 2 records each. 6 divided by 2 gives me 3 intervals. Now what happens is I go into each interval and I pick a record. So I decide when I go into this record, I'm going to pick the first record in this interval. So I'll end up picking that one. I need to now pick the same record in the next interval. So I need to pick the first record in this interval. And I need to go into the next interval and pick the first record in this interval. So because I decided to pick the first record in the first interval, I need to pick the first record in every subsequent interval. So the intervals I first created, they have the same fixed size, and then I go into each and I pick the same record. Now, of course, I don't have to do it like that. I could say, right, I've created my intervals, 2 records in size. But when I go into the first interval, I want to pick the second record there, fine. But then I have to go and pick the second record in every single other interval. So whichever record you choose to pick in the first interval, you must pick the corresponding record in the next interval. So that's the fixed interval method. Create intervals of the same fixed size, and then you can pick the first record. Now, let me just have a look at this. Suppose my data was slightly different. Suppose I had a 7th record, maybe for $4 or something, right? And I said I want intervals of 2 records. Well, there I've got 3 intervals of 2 records. Unfortunately, I can't form an interval here with 2 records because there's only 1. So my last interval will be only one record, will consist of only one record. So ACL, create the intervals you want, but the last one might be short of a certain number of records, but that's fine. Now, if I decide to choose the first record, I'm going to have a sample consisting of these transactions, right? The first one in each interval. So I will have a sample eventually of size 4. But if I decided to go and choose the second record in each interval, what I would see is that I don't have a second record in my last interval. So I will have a sample with only 3 records. You can't pick a non-existent record from that last interval. So if you know that you want a sample size of 4 records, and you want to use a fixed interval method for record sampling, and you've decided based on this data, you're going to have 2 records per interval, you need to be careful. You need to think carefully, which record should I take from each interval, the first, the second? Well, I would have to take the first record if I wanted a sample size of 4. So you would have to do a calculation to see what would happen. So I've got 7 records divided by 2. Does that give me how many intervals? 3 point something. Okay, so in other words, I'll have 3 complete intervals of 2 and one interval with, less than 2. Well, the only number less than 2 will be 1 in this case. So that tells me I've got to take the first record in each interval if I want to get 4 records. Now let's go to the AR table. I want to take a sample from here. I want to use record sampling. I want to pick record numbers, in other words. And I want to create fixed intervals. Now, let's say I decide I want to choose to have intervals of 2 records in an interval. That's going to give me a very big sample because I have 772 records. I'm going to have approximately 360, 370 or so records, actually more than that, about 380 records. The point is, I will have a large number of records in my sample, which is not what I want. So if I've got a bigger data set than what I had in Excel, I need to rather make my intervals bigger in size. So let's suppose I want to let's suppose I know the size of the sample I want. I want to have eventually 30 transactions. So I could do a calculation. And I've got to say, I've got 772 transactions divided by 30 records. 30 records that I want to pick. So that means basically I need 30 intervals in theory. So I need to have 25.7 records in an interval. Now you can't have 25.7. So my thinking is we should have 25 records per interval. So let's just do a check. If I take 25 and I multiply by 30, I will get 750 records. I'm going to have an interval with a last interval with 772 minus 750. My final interval will have 22 records. Now, so what I'm saying is I'm going to have 31 intervals in total if I choose a size of 25. And I only want a sample size of 30 records. So I need to make sure I don't pick anything from the last interval. So I need to pick anywhere from record 23 up to record 25. This is my thinking. So let's try this. Let's see if I can get, using intervals of size 25, exactly 30 records. Right, so I'm going to go to sampling. I'm going to go to the first option and I'll choose sample. And then I'm going to choose record. I want to use fixed interval. Now my interval size I calculated is 25. Start. Now start means, do you want to pick the first record? And if I pick the first record, I'm going to pick the first record from the last interval too. Let me try pick the 23rd one. I can pick anywhere up to number 25 for these intervals because they all have, except for the last one, 25 records. Now I'm going to call this new table sample record fixed. And I'm hoping that I will get exactly 30 records based on the calculations I did. If I don't get 30 records, it means my calculations are wrong and I need to go back to the drawing board. Right, so I'm going to click OK. And there I got exactly 30 records. So that's the good news. All right, so let me go back to the AR table. Now, with fixed interval, the one of the arguments, again, I'm not going to get into a lot of detail here, but one of the arguments in favor of it is it's not like random sampling where you randomly pick something and who knows if you pick nonsense. With fixed interval, you're breaking things up so that every so often you pick a transaction. You make sure that you're not picking things just close to one another. You're picking them all over. But a counter argument, of course, is if the data isn't sorted in any meaningful way, such as by transaction value, well, then you're picking, maybe only small amounts by accident or only big amounts or something like that. So you could say, well, first sort it by amount in ascending, then create your intervals, and then you can pick. But then again, someone could argue you're going to pick lots of small amounts if most of your amounts are small because you've got lots of intervals now with small amounts. And someone else could argue that fixed interval is good if you sort it by date because you're not skipping out entire weeks or entire months. You've sorted it by date, so every interval has at least one transaction from a certain month. You can argue these things back and forth. But the point is you need to decide in the office as an auditor, or the client rather needs to decide which type of sampling methodology they're going to use. For us in ACL, it's a case of once they tell us what it is they want to use, we just script it, right? We just use the mouse and then we just copy the script from the log. All right, so that was fixed interval. Now let me go back to Excel. I decide that I want to use record sampling. I want to pick record numbers, but what I want to do is I want to do cell sampling. Now, cell sampling is a combination of fixed interval and random. So the first step is to create your cells, your fixed intervals. And I decide I want cells of 2 each. So 2, 2, 2, they are my cells. Again, if I have 7 records, based on this data, my last cell will not have 2 records, but that's fine. Now what happens is I use the random part of cell sampling. I go into the first cell, into the first interval. Instead of saying I'm always going to pick the first record or always the second record, I close my eyes and I see what I pick. Now maybe when I close my eyes, I pick that record. Now I go to the next interval, I close my eyes, maybe I pick that record. Go to the next interval, close my eyes, I pick that record. If I do have another interval, I close my eyes, well, there's not much choice there. I'll be able to pick only that one. So it is random within each cell. So each cell has the same size, except possibly for the last one, which might have fewer records than 2 or whatever the sample size is. So some people might say, okay, I don't want to necessarily pick always the second or the third transaction in interval. I want to make sure I get all the, something from each month. So they sort it by dates, and then they use fixed interval, the cell sampling method, so that they can divide this into intervals, into cells, but they randomly select a transaction from each cell. All right, let me just undo some of this for later on. Okay. All right, so let me do this in my AR table. So I go to sampling, and I go to the first option, and I go to sample. I want to choose records, and I want to use cell sampling. And I want to say, okay, how many records per interval? Now, again, I could, if I wanted to calculate how many records I want. So I'm going to stick with 25, right? An interval of 25, because I'm hoping to get 30, but of course I will not get 30. Because the last interval, something will be selected because I'm not getting to stipulate which record. And I want to do this, sorry, I've chosen cell sampling already, and I'm going to call my new table sample. Let me call it record cell. And you see there, I've got 31 records because ACL went into the last interval and it randomly selected something from there. So I can get close to the 30, but I will usually get one more than I wanted if I use cell sampling. Now, before I talk about monetary unit sampling, let me go back to this random sampling. Okay, so when I do take a record, I randomly select it. I see there's this option called seed, which I didn't bother to fill in. Now, seed just means a number. Now, let's think about random sampling. If I print out a list of records for you, and I say to you, randomly select some records for me, you can close your eyes and see where on the page your pen lands, and there you have randomly selected your records. Now, computer program cannot randomly select like that. It doesn't have eyes, it doesn't have a pen. So what it does is it uses a formula. Now, let's say for argument's sake that there is a formula in ACL that looks like this, right? Let's say that's the formula. If I give ACL a seed of 4, a number 4, what it will do is this calculation. 4 plus 5 will give me 9. it will pick record 9 and put that into my sample. It then takes that number 9 and it sticks it back into that formula and it gets 14, and it now chooses record 14. Now, obviously, that's not a very random formula. That's a very predictable formula. So the formula in ACL is extremely complex. And some people say if it's a formula, it's not random. That's not actually true. You can find the equation of many, many graphs in mathematics, but some are so bizarre. If you draw them, they go all over the show. It would take you years to figure out the equation because the pattern seems to be so unusual. And let me tell you, when you close your eyes and you let your pen land wherever, you might say that's random and not the formula, but actually what you're doing is as random as the formula, or even less random actually than the formula. Random just means really, it's very difficult to predict what's going to happen. And the truth of the matter, mathematically speaking, is that what you do with a pen when you close your eyes, the results you get, those are actually mathematically predictable to some extent. So this whole idea of of things being completely random, whether you do it with a pen or formula, it's a bit of a misnomer. Nothing in the universe is truly random the way we've been taught to think about it. But some things are close to random. So that formula built into ACL, whatever it is, not this x plus 5, that's not the formula. That formula is actually very, very, very random based on the way we understand random. Okay, it would take you a very long time to try to figure out what that formula was. Okay, so I could then put in a seed if I wanted to. Now, when you put in a seed, what will happen is if you put the same seed in there, if you put, let's say, the seed of 4, and you come back and do the exact same sample exercise with the same AR table, with the same settings, including the same seed, you'll get the same result again. So sometimes external auditors want to be able to replicate the sample, the random sample we took. So then you choose a seed. And when the external auditors come, you say, okay, I chose 4, for example. That doesn't have to be 4. It can be 3.912. Knock yourself out, any seed. Now, I did not choose a seed for the examples I did. But the truth is, because there's a formula in the background, you need a seed to substitute for X. So if I don't choose a seed, ACL will choose it for me. If I go to my log, and let me just choose one of these random ones. Let's just see here. All right, this is a random one, I think. Let me double click that. And over here somewhere, let's just see here, top stratum, there's the seed that ACL chose. It's generated a seed of its own. So if I don't choose a seed and I want the external auditors to be able to replicate the sample when they come, I need to quickly make a note after I've taken the sample of what seed ACL used. So if the auditors plug in all my settings, including that seed that ACL chose, they will get the exact same sample as me. All right. So that is record sampling for the most part. I just want to point out something else to you. So when I take a random sample, let's talk about record here, right? There's also this option, this algorithm, Mersenne twister or the default. Now, really, it's called an algorithm, but basically, though there are 2 different formulas here in ACL. The default formula and this formula called Mersenne twister. It doesn't matter which one you choose, honestly. It's going to be random. It honestly doesn't matter. So, but if you're fussy, you can go and choose default. You're fussy, you can choose Mersenne. Honestly, I don't care in the real world. To me, it's already random. If you want to get into a whole long discussion, I think people end up splitting hairs and talking nonsense, to be honest, and chasing their own tails. It doesn't matter to me which one you choose. Whatever result you get is going to be random. Okay. So now, let us talk about monetary unit sampling, and this is the tricky one. At least part of it is. So let me go back to Excel first. This is my data. And I decide I don't want to use the sampling type record sampling. I want to use monetary unit sampling, which means I'm going to select the monetary units. I'm going to pick the amounts. Now, if I change my mind just very quickly for a moment back to using record sampling, remember, I might choose that amount. Let's say I do this randomly. I might choose that record there. I might choose that record there for argument's sake. If I do this randomly using record sampling, I've picked record 2 and record 6. And record 2, of course, has a transaction value of 3, and record 6 has a transaction value of 1. Now, if I do the same thing again, but this time I decide, no, I want to do monetary unit sampling randomly, I'm going to randomly select from this column. and maybe I randomly select this one here, and maybe I randomly select this one here. Now you might say, but hang on, there's no difference really. You're selecting randomly in this column or randomly in that column. It doesn't matter because, for example, when you randomly selected a record number, you picked at $3. When you randomly selected the $3, you picked record number 2. So what's the difference? The difference is that monetary unit sampling has a very specific philosophy built into it. The philosophy behind monetary unit sampling is it is not the small amounts that will make your organization go bankrupt. It's the big amounts. It is designed specifically to look for the bigger amounts. So I'm not saying that if you take monetary unit sampling and look in this column, that ACL will never pick the 1. It could, but it is less likely. It is much more likely to pick the bigger amounts. It's designed to look for the bigger amounts. And of course, you could say, well, that makes sense. But then someone else would offer the counter argument, but lots of small amounts are material as well. And some people might be hiding things by processing lots of small amounts. So again, you can have this argument with yourself or with someone else about whether you should use record sampling or monetary unit sampling. And irrespective of which type you use, should you use fixed interval or self-sampling or random sampling? And honestly, the answer depends on each organization and each data set and what you're looking for. That's the honest truth. I don't think there's a rule that says always use this or this or this. Anyway, so now I want to tell you in more detail how this monetary unit sampling works. First, explaining in Excel. So when I choose monetary unit sampling, if this was my original table, ACL doesn't actually use the original table as the basis for my sample, not directly anyway. It kind of recreates this table. So in the background, imagine that ACL creates another table. And record number 1, the amount was for $2, £2, 2 kwacha, whatever it was, right? Because the amount is 2, I need to write down in my new table, well, ACL will write down in the new table, this transaction, this record 1 twice, once for each kwacha value. Then in this original table, there was record 2, which had a value of €3 or whatever the currency is. So when I paste this, or I need to paste it in the new table 3 times because the value of that transaction was 3. This transaction is worth $1, so it's going to be there once. This one here was worth, let's say, 4 metikash if we're working in Mozambique. So it's going to appear 4 times. This one is going to appear twice. And then finally, we're going to have that record 6 for $1. Now you can understand why I kept these amounts small. Imagine if I had made that 2 million, I'd be copying and pasting forever. Right, so this is effectively the table now that ACL has in the background. And it uses this new table, not the original, to take the monetary sample from. So let's suppose I decided to randomly select monetary units. So I would look in this column. I'm going to, let's say I want to choose 3 of them randomly. I close my eyes and maybe my pen lands there. I close my eyes again and it lands there this time. I close my eyes again and it lands there this time. Now, notice what has happened. I've picked record 4 for 4 Rand or whatever the currency is twice. This is one of the downsides of monetary unit sampling. You sometimes accidentally pick the same record more than once. The bigger the amount, the bigger the chance that you are going to pick that same amount, right? So this is the downside of it. It's very difficult or maybe even impossible to control your sample size with monetary unit sampling because you want, let's say, 30 records, but in effect, I don't have 30. I've got 30 minus 1, let's say, because I picked the same record twice. Now notice, by the way, this 4 appears 4 times. This 1 appears once. The bigger the amount, the bigger the chances. In the original data, the more times it appears, therefore the bigger chance, the bigger the chance it will be selected. So this is 4 times more likely to be selected than that one. Now, to be honest, in this table in the background, there is another column. And this column consists of only that, 1, 1, 1, 1, 1. So what ACL actually does is it doesn't select at 3, it randomly selects once. So it might select that one, and that one, which obviously is associated with those records in the new table. That one is associated with that record, which in the original table was record 2 for $3. This one is associated with this record 4 from the original table for $4, and this one with that record 4 from the original table. Doesn't matter, you know, that I chose it in this column here in Excel. The fact is, if you choose the ones here, which is what ACL actually does, you will get the same result as what I got. But this column is important to be aware of, because when it's not random, it's not possible to understand exactly what's going on with that column. Right. So let me undo this highlighting. I don't want to highlight any of this yet. Let's go do this in ACL. I want to randomly select monetary unit values. Now, I might get lucky for video purposes and select the same transaction twice. I might get unlucky. Sometimes I get duplicates, sometimes I don't. Obviously, the bigger the amounts and the bigger my data set, the better the chances that I'm going to pick duplicate amounts, duplicate transactions. So I'm going to go to sampling. I'm going to, now before I go to sampling, by the way, I'm going to add up. I'm going to total my amount column, because the population size now is not in is not in the number of records. We're doing monetary unit sampling. It is the total transaction value. That's often the population size. So I'm just totaling it in case I need it. So I'm going to go to sampling. First option, choose sample, and oopsie. I'm going to choose monetary unit sampling, and I decide I want to randomly select things. Now, the population size, you see there. I'm going to paste that value in there. That's the total. And the size of the sample still is a physical number of records here. I want 30. So if you randomly select, you have some control of the size of the sample, but again, I'm aiming for 30. If I get duplicates, I might effectively only end up with 28, let's say. So I'm going to put this in a new table. I'll call it sample MUS random. I'm hoping for duplicates so I can show you. If I don't get, well, it's fine. If you do this enough times in the office, you'll get duplicates at some point. Right, so I'm going to click OK. And I'm just quickly going to look at duplicates. In fact, I don't need to. I can see already there's a duplicate. You see there. There's a duplicate transaction there. There might be others. So let's suppose that was the only duplicate. It looks like I've got 30 records in the sample, but the truth is I don't have 30. I've got 29 if I'm lucky. I haven't checked the other things. Right, so I've got at most 29 records. Do you see now I'm going to struggle to control my sample size because of this duplication issue. So I might think to myself, okay, there's a solution here, I think, but this is not a proper solution. I'm going to go to this first option, choose sample. I want to do monetary unit sampling. I want to do it on the amount field, by the way. I want to do it randomly. Now, the settings would be the same, right? There's my population size. There's 30. And I'm not going to worry about putting anything there right now, but under the More tab, there is this option at the bottom, no repeats. So that duplicate I had would not appear in my sample table. So if I chose, if monetary unit sampling chose that one record twice, the way it actually did when I did this monetary unit sampling a few minutes ago, it wouldn't appear, I wouldn't have 30 records in that table. I would have 29 immediately. So it would remove the one duplicate. Now that's good news. The bad news is it doesn't replace it with something. It doesn't say, hang on, I've now only got 29 records. This auditor wants 30 records in their sample. Let me go fetch another one. It just leaves it. So it removes the duplicate, but that's where it stops. So great, I can remove the repeats, but it doesn't actually replace it. So that's a bit of a problem, right? So monetary unit sampling, it can be tricky to control your sample size. It might even be impossible, as I said. Okay, now I decide I want to do monetary unit sampling, which means effectively, whether I realize it or not, I'm using this table in the background. But I don't want to randomly select my unit values, my dollar values. I decide I want to use fixed interval method. Now the fixed intervals here are not based on record numbers. You don't say, oh, there's 2 records in an interval. We're looking at monetary units. What happens is we are going to create intervals. And when you total the dollar values in each interval, they should total to the same thing, except maybe for the last interval. So I decide I want intervals of $7, let's say. So I'm going to look at that column with the ones now. 1, 2, 3, 4, 5, 6, 7. All right, there's the end of my first interval. 1, 2, 3, 4, 5, 6. Well, I don't have 7, but that's fine. The last interval then will have whatever is left over of the table. So again, with fixed interval, even though it's monetary unit sampling, there's a good chance that your last interval will not have exactly $7 or whatever the total is supposed to be in an interval. Now, I've got the fixed interval. Now I need to go and choose a record from each interval. Now, suppose again, this is not based on record number. This is based on monetary units. So I'm going to use the concept of totals again, subtotals. I'm going to see if I add up the ones, where do I get $4? So let's see, if I start adding, 1 plus 1 is 2, 3, 4. So if I add all those amounts up to and including this one, I'll get $4, right? Because this is where I get $4, I'm going to pick that record. That's going to go into my sample, right? Now let me go to the next interval, 1, 2, 3, 4. I want to pick that one. So I'm going to have, based on this data and the way I've designed the intervals and the records I've chosen, I'm going to end up picking those two transactions. Now, if I chose the one for $7, I would get that one in my sample, because that's obviously 7, and there would be nothing here because it only goes up to 6. So my sample would have only one record instead of 2 if I chose the record where where I eventually add up the ones to give me a subtotal of 7. So that's what happens with fixed intervals. So let me go do this in ACL. I want to go take a sample. I'm going to use the first option, sample. And I want monetary unit sampling. I want fixed interval. Now the interval size. Now this is tricky. How do I know what the interval size should be? I don't want to make it $7 because look, I've got amounts of 474, 225, 1,600. If I make it $7, just about every transaction will be in an interval on its own. I'm going to end up choosing the same thing multiple times. So I'd have to get some statistics to get, before I come here to see what's the highest value, the lowest value, and so on. Now I already know the data more or less. So I'm going to say, okay, based on what I know about the high, low values, the totals, let me try maybe having $10,000 in an interval. And the start, I want to select wherever it adds up to 4,500. Now this cutoff, you see it with monetary unit sampling with fixed interval. This cutoff means everything above a certain threshold has to be in your sample. It has to be audited. So let's say I put 4,000. What that means is ACL is going to do a filter in the background. Everything in here with the value above 4,000 will automatically go to your new table. So that's not really a sample as such. Then it will change the filter to look for things in this AR table below 4,000. And it will apply, and it will divide only those into intervals of $10,000 each, and then we'll pick the 4,500th unit in each, except maybe for the last one because it might not exist there. And it will basically append it to everything above my cutoff, above my materiality. All right, so this is a sample, it's MUS, it is fixed interval, and I'm going to click on OK. And I've got 60 records. Now, you could manually do this as an exercise, manually go to the AR table and add up where does your first interval end. It might be a bit of a schlep to do it because you've got to put 111 somewhere, right? And then you'll be able to see why ACL picked that particular one. And you'll see that's the 4,500, mark thing, just to see. Or what you could do if you want to see better is use this data, maybe export it to XR, and then just change all the transaction amounts to very small amounts. So it's easier for you to manually check which ones you think should be selected, and then verify that ACL does select the ones that you thought it should. Okay, that's how you actually get to understand monetary unit sampling better, by actually importing data with small amounts into ACL, predicting beforehand which ones you think ACL is going to pick, and then verifying if your logic is correct. All right, so these are the transactions that's selected. Now, this is very difficult to control the size here, very difficult. How do you know based on amounts which interval, how many intervals you're going to get? Is it even possible to guess? I doubt, to figure this out, I doubt it. Anyway, now monetary unit sampling, what you could do in theory, again, I'm not saying this is what you should do. This is just an idea. This is just something you can debate with yourself or with someone else. Is you could say, I'm going to sort all these transactions in the AR table by amount first, ascending order. So what happens is my first few intervals will have lots and lots of records in because they have small amounts, and those small amounts, we need lots of them to make up the total of 10,000 or whatever it is the total is. So we're only going to pick a few small amounts, and then the bigger amounts, there will be a lot more intervals with the bigger amounts because a few big amounts make up an interval quickly. So we'll end up picking some small amounts, and a lot of big amounts. Because if you don't sort the data by amount, your monetary unit sampling is unlikely to pick a lot of the small amounts. We'll pick very few of them, if any. If you want to include some of the small amounts, maybe sort the data first by in ascending order by the amount, and then you will have at least some small amounts once you've selected from the intervals. All right, now I decide, wait a second, I want to do monetary unit sampling, but I don't think we should, for whatever reason, use the fixed interval method. We should use self-sampling. Now remember, self-sampling is a combination of fixed interval and random. So I'm going to create a cell of $7, let's say. There we go, $7. Unfortunately, I didn't have $7 here, but that's fine. I'll use what I've got. And then instead of choosing the same one in every single interval, I'm going to randomly select one. I'm going to close my eyes and see where it lands. Okay, my pen lands there. Now I'm going to go to the next interval, close my eyes, see where my pen lands, and it lands there. Now notice what happened. I accidentally selected the same record twice. Remember, this is the major hazard of monetary unit sampling. No matter which method you use, random, fixed interval, or self-sampling, there is the possibility that you are going to pick the same transaction more than once for your sample. And it's all very well saying I'm going to go to the More tab because I don't want to see this duplicate, but then instead of showing me two records, it's going to show me only one. It's not going to go back to this interval and choose a different one. It's just going to say, oh, well, fine, I'm not showing you this selection because you've already selected it. You're only getting one record and not two. So it is very difficult to control. Okay. So if your data isn't sorted in any particular order, you can say, well, I'm going to break it up into intervals, and maybe some will have a small amount, which will kind of give them a bigger chance of being selected, but not too big a chance. You can argue this back and forth, as I said, monetary unit sampling or record sampling, fixed or random, or do you want to have, self-sampling? Now remember the cutoff we said was 4,000. So let me see if there are any transaction values here above 4,000. Amount greater than 4,000, right? This is my sample table. And I have 3 of them, exactly 3. Now, if I go to my AR table, the original data before the sample, I want to check how many transactions have a value above 4,000. And it turns out there are exactly 3. So everything above that threshold was actually pulled through automatically. The sampling happened on things below that threshold, right? That's monetary unit sampling. Now, an interesting question to ask would be maybe, are there any amounts, credit values below negative 4,000? Now, it turns out that there are none in the starter. Okay, so there won't be any in the trans table. So what you could do as an exercise, or if you wanted to, was do this monetary unit sampling with the fixed interval, but change your threshold, your materiality, right, to something smaller, maybe minus 2,000, and see if they all pull through, because the absolute value of minus 2,000 would be 2,000. You can try that as an experiment just to see what happens, right? Okay, so that was monetary unit sampling so far. I want to do it in ACL again, the monetary unit sampling, but this time using self-sampling. So I'm going to go to sampling, the first option, sample. And I'm going to say I want monetary unit sampling, and I'm going to choose self-sampling. And my intervals, let me make up an interval, 10,000, let's say. Again, the seed, we know what that is. It plugs into a formula, but if you don't put it, ACL will randomly choose a seed. Cut off, I'll make it, well, make it low this time. Let's do 2,000, why not? We might as well try that experiment while we're doing this exercise. Sample MUS cell, and click on OK. Now, I get 89 records. Now, let's just check something here. I'm going to do a filter, amount less than negative 2,000, right? And I get 4 records. Let's just check, as a matter of interest, in the AR table, how many transactions have that value. Okay, exactly 4. So the moral of the story is, when you put that threshold, even though you might put positive 2,000, ACL takes the absolute value of the amounts, because it realizes that, yes, it thinks mathematically, but we might be talking debits and credits. So credit of 3,582 is bigger than a credit of 2,000. So it will pull through the negatives below negative 2,000, so the credits above 2,000 in the starter, and we'll pull through the debits, the positives above 2,000 as well. So that's what's going to happen there. Now let me go back to the AR table, and I decide, once again, I want to do some sampling, right? I want to go to the first option, and I'm now not sure, honestly, let's say I want to do record sampling again, and I want to randomly select 30 records from here. Well, I'm not sure, is 30 actually the right sample size? Is it a valid sample size? Should I maybe pick 10? Should I pick 100? I'm not sure. So I'm going to go to this option here, calculate size. And because I want to do record sampling, I'll choose that. Now I need to indicate my confidence level. Now remember, confidence level with sampling means how certain do you want to be that the sample you get is representative of what happened in the population? So the transactions I get, how certain am I that the transactions in my sample will accurately tell me where the controls failed, etc., in the entire data? So I want to be maybe 95% certain. The population size is 772 because that's how many records I have in this table. The expected error rate, based on my previous audits of the AR data, let's say I'm used to seeing 2% of all the records, so 2% of 772 or 2% of whatever it is, they tend to have errors. Now, upper error limit, that's my tolerance. Let's say I make it 5. What that means is things might have gone wrong in this organization this year. A lot of controls failed. So if up to 5% of things in the data went wrong, I'm prepared to still, work with the sample to figure out what projections there are and so forth. Using the sample project what happened in the organization in the full data set. The thing is, if it's more than 5%, I wouldn't dare try to use a sample to project what's going on. So I obviously have to check afterwards when I start doing my audits, tests, what percentage, of this error actually happened. Anyway, so I've put these settings and I'm going to click on calculate. So based on this, I should take a sample size of 184. Okay. Now, if I do decide to do fixed interval sampling, I need to choose 4 intervals of 4.19, so in other words, 4 and so forth. So you could calculate the sample size. Now, honestly, I wouldn't use this. I would not use this size option at all. In the old days of auditing, before cars and airplanes, before people started using horses, all right, even. So in the old days of auditing, what happened was we had too many transactions to audit. We had to take a sample. The problem with a sample was, how do you know you've chosen a sample that accurately represents the population? You don't want to take a sample, say everything's fine or everything is wrong, and then incorrectly draw the conclusion everything in the data is fine or everything in the data is wrong. You need to make sure the sample is valid. So you had to calculate what a valid sample size was, etc., etc. We now have something called ACL. We have this product, AN, this amazing program. So what I would recommend normally is you take your data, you analyze 100% of it, all 20 million records. Once you have your exceptions or your possible exceptions, if you decide you need to physically trace some or go look at the physical paperwork for some of them, go take a sample from there. And honestly, so instead of looking at 10 million transactions saying out of 10 million, let me pick 100 and, hopefully I can see what's going on in the data. Hopefully I picked a valid sample. Just take the 10 million, analyze all of them and get 100 exceptions. Then, no matter which one you pick, you're probably going to pick up some issues in the paperwork. And to be honest, you can just randomly pick some, unless you really want to get fancy with unit sampling and all that. But you don't need to worry about the sample size because you're sampling not on the full data set, you're sampling on a very small subset, a subset of the exceptions. You are extremely focused. So this here, honestly, I think is for the most part for people who are still living in the old days, who don't want to be dragged kicking and screaming into the modern age of more efficiency, of great efficiency, of finding more exceptions and so forth. So I wouldn't use that. You could, but I wouldn't waste my time using it. Now, if I go straight to my sample command, by the way, there's a size button. Yeah, it's the same size button. I don't see the point. If I'm really going to use size, why go to sampling in size when I can just come down here and put it in here because it's going to type it for me. If I use the size option where I was, I have to now manually come and type it in here. I don't want to do that. I just go here. Now I'm going to come here and I'm going to do something. I'm going to play with the settings just to see if I can get some ridiculous results. Okay, I want the size button. I want 95% confidence. Let me make that 3. Let me make that 2. I'm trying to get some unusual result here. I click calculate. So based on my parameters, the sample size I should take is 850. So I have 772 records in the AR table. I need to audit 850 of them. Now, that doesn't make sense. That's not physically possible. what you need to understand is, okay, and this is a famous ACDA question, is that behind all this theory about sampling is something called distribution theory. So if we think of it from an audit point of view, we want to know where in my data are the exceptions? How are they distributed? So does someone violate the policies of the organization or make a mistake every fifth record? So if that's the case, I would look at transaction 5, then transaction 10, then transaction 15. Unfortunately, it's not that simple, but I'm trying to understand how the errors are distributed in my data. So statisticians have tried to predict this in the case of auditing, for example. How do we know where they're distributed? And they came up with different theories to try and predict and understand and explain where these errors and things are distributed. And there are two theories. There's something called Poisson Distribution, named after the French mathematician Frédéric Poisson. Distribution. Goodness gracious me, I can't type. And there's another thing called binomial distribution, another theory. Now, if you have a large data set, 10 million records, let's say 1 million records, maybe 100,000 records or something, both of these will actually give you the same predictions about more or less where the errors will be. And then your samples would be the same no matter which method you used. But if you have a small data set, this first method will give you some really ridiculous answers sometimes. Guess which method ACL uses? It uses the first one, Poisson Distribution. On a small data set, it is possible that you'll get some nonsense, such as take 850 out of the 772 records and analyze that. This is because Poisson distribution tends to be inaccurate on small data sets. But if it's inaccurate, then why did ACL choose it? The reason is simple. It processes a lot faster than binomial. Now, in theory, if I'm going to be very old school auditing, I would take a sample on a huge data set. But if I'm modern school, I'm going to randomly select from my exceptions. And I'm not going to even bother calculating the size. I'm just going to randomly select from my exceptions, and I'm going to find some other issue. So these things are there because some people still want to do things the way they were done in 1822. Let them stay there, but please, I don't want you to stay there. We've got this amazing tool that helps us. Sampling has a very different role as far as I'm concerned now in ACL, and in auditing, sample the exceptions. Okay. All right, so that was sampling, record sampling, and mandatory unit sampling. I hope that helped you if you haven't seen all of those in detail before. As I said, classical variable sampling is another story, but frankly, I wouldn't even use it. I would just stick with record sampling and the random option and use it on exceptions. Right, well, I hope you have a good day, and I shall see you in a previous video, either time machine, or I shall see you in a future video.